On a sunny day, while sweating and feeling irritated, completely drained of energy, have you ever wished for multiple suns for our Mother Earth? Haha, just kidding. But we've all wished for this during cold times, when clothes wouldn't dry. In a solar mistake, what if our Earth had multiple suns? Like when 3 suns appeared back in 2015 in Mongolia. But that was a sundog. What if it happened for real? Before we imagine the surreal beauty or terrifying chaos of 2 suns blazing in our sky, let's revisit how we came to believe in just one. For most of human history, we thought the Earth was the center of everything. It wasn't until Nicholas Copernicus introduced the heliocentric model in the 16th century that we finally gave the sun the spotlight it deserved. But long before him, Greek astronomer Aristarchus of Samos proposed a similar model, one where Earth revolved around the sun. These revolutionary ideas turned the universe inside out. Still, it's strange to think how normal we consider one sun, when in reality our solar system is actually the odd one out. In fact, binary and multiple star systems are more common in the galaxy than solo stars like our own. Our sun might just be a cosmic loner. Binary systems, where 2 stars orbit a common center of gravity, dominate our galactic neighborhood. Over half of the bright stars you see in the night sky are actually double or even triple systems. Our nearest stellar neighbor, Alpha Centauri, isn't a single star but a 3-star ensemble, waltzing together in a cosmic dance. So why didn't we get 2 suns? Some scientists believe we almost did. During the birth of our solar system, it's hypothesized that our sun had a partner, a twin of sorts, nicknamed Nemesis. This hypothetical star might have drifted away or been ejected during the violent early formation of our system. If Nemesis had stayed, Earth might have been caught in a binary gravitational web, and life, as we know it, would have unfolded very differently. So, what would this alternate Earth look like, living under the gaze of 2 stars? Imagine 2 sunsets, one fading in amber while the other dips in crimson, casting double shadows behind every tree. The drama begins with the configuration of the stars themselves. In one version, our second sun could be a smaller star, perhaps 80% the mass of our current sun, orbiting at the distance of Saturn. Surprisingly, such a setup would be stable. We know this because similar binary star systems exist, where planets maintain predictable orbits. Earth wouldn't be flung into chaos, but instead would experience an entirely different rhythm of life. The seasons on 2 Sun Earth wouldn't be as extreme as one might assume. When both stars aligned on one side of the planet, we'd get intensified summers, about 10 to 15% hotter than what we know now. But when they sat opposite each other in the sky, their energies would balance out, creating gentler transitions between seasons. Daylight patterns would become more complex but still regular, a ballet of brightness and shadow. We wouldn't face endless days or frozen nights. Instead, a new celestial pattern would write the rules of our days. Tides, though crucial to life, wouldn't dramatically change. Our moon would still dominate Earth's tidal mechanics, but the second sun would add subtle new rhythms, whispers in the water rather than crashing waves. However, life itself would wear the signature of dual sunlight. Plants would evolve new types of photosynthesis to juggle the changing light dynamics. Some might learn to follow both suns across the sky, while others might specialize in absorbing the rays of just one. This would create an explosion of plant diversity, landscapes shimmering in alien hues. And then the animals, now things get wildly imaginative. Under 2 stars, evolution would push eyes to adapt to a broader spectrum of light. Humans might have evolved vision that includes infrared, like snakes, or ultraviolet, like bees. Imagine seeing colors we currently can't even describe. Our skin too might have evolved differently, perhaps more resistant to light, or even reactive to multiple spectrums. Nocturnal creatures might base their sleep cycles not on a single nightfall, but on the complicated interplay of 2 setting suns. And human civilization, entirely transformed. Early astronomers would be tracking not just one moving object in the sky, but two, forming a much deeper understanding of orbits, alignments, and time. Calendars would be built around dual celestial patterns. Science, too, might have advanced faster. Observing gravitational interactions between two stars would offer easier paths to understanding physics. Space travel, while more complex due to dual gravitational pulls, would begin with stronger motivation. Perhaps humans on two-sun Earth would seek to find triple sun systems and colonize them. Binary star logic would become our baseline, not the exception. But what if Earth didn't just orbit two suns, but three? This brings us directly into one of the most mind-bending scenarios in astrophysics, the three-body problem. Put simply, the three-body problem explores what happens when you try to calculate the gravitational interaction between three massive objects, like stars, at once. The result? Pure chaos. First, the three-body problem isn't just math, it's chaos theory in motion. There are no fixed answers, only probabilities. That's why triple-star systems in reality are either extremely rare or structured in very specific orbital hierarchies, like two stars orbiting each other closely while a third orbits from a much greater distance. Balance requires a symmetry. Second, if Earth were in a three-star system, human existence as we know it might be impossible. Seasons wouldn't exist in any predictable way. Temperature would fluctuate wildly. One sun might rise while another sets. Or worse, multiple suns could rise together and fry the surface. Then, without warning, Earth could be ejected from the system altogether, doomed to freeze in the vastness of interstellar space. And it gets darker. Earth would need to maintain a much wider orbit just to avoid getting torn apart by gravitational tug-of-war. In one scenario, we'd circle two stars in a fragile, circumbinary orbit. In another, Earth might cling to just one sun while the other two spiral around from a distance, forming a hierarchical triple-star system. Why? Because gravitational instability could throw everything off balance. Wild temperature swings, unpredictable seasons, a twisted orbit, and at any moment, Earth could be slingshotted out of the habitable zone, flung into frozen oblivion between the stars. Beyond gravitational concerns, the intensity and variability of solar radiation would escalate to extreme levels in a system with multiple suns. Currently, our sun operates as a stable and powerful nuclear engine, a massive ball of hydrogen and helium with energy generated in its core through nuclear fusion. This energy, produced under crushing pressure and temperatures of over 27 degrees Fahrenheit, travels outward through the radiative and convection zones before reaching the surface. It eventually escapes from the photosphere, the visible surface of the sun, providing a consistent and life-sustaining stream of light and heat. Now imagine more than one such sun shining on Earth. The incoming solar energy, known as insolation, could easily double or even triple, depending on the types and proximity of the added stars. This excess energy wouldn't just make things hotter, it would set off a dangerous chain reaction in Earth's climate system. Increased ultraviolet and possibly X-ray radiation could rapidly erode the ozone layer, a vital shield that protects life from harmful ionizing radiation. Without it, radiation would reach the surface more directly, damaging DNA in living organisms. Meanwhile, Earth's greenhouse effect could spiral out of control, like a cosmic version of Venus's fate, where the oceans begin to evaporate, water vapor traps more heat, and carbon dioxide builds up to suffocating levels. But that's not all. Space weather around Earth would become an unpredictable and hazardous battlefield. The sun doesn't just give off light, it also releases a constant flow of charged particles from the outermost layer of its atmosphere, the corona, known as the solar wind. This stream of plasma travels across the solar system, forming a protective magnetic bubble called the heliosphere. Earth lives within this bubble, and our planet's own magnetosphere deflects much of this solar wind, shielding us from its harmful effects. In a system with multiple suns, each star would contribute its own solar wind and magnetic field. These multiple winds and fields would crash into each other, merge and create violent disruptions within the heliosphere. Earth's magnetosphere could be squeezed, stretched, or thrown into disarray. The results would be catastrophic. Geomagnetic storms would become frequent and far more powerful, capable of disabling satellites, knocking out entire power grids, and wreaking havoc on global communications and navigation systems. In such a high-energy, chaotic environment, the sun's gentle glow that now sustains life would become a blazing threat, transforming Earth from a nurturing home into a hostile, unstable world. The night sky itself would vanish as a concept. If the stars are close enough to remain above the horizon most of the time, darkness would become a rare event. This would disrupt ecosystems that rely on diurnal or nocturnal cycles and could fundamentally change how vision evolved in animals, as we already explored. For humans, chronic exposure to multiple light sources could affect melatonin production, increase the risks of insomnia and cancer, and alter psychological rhythms at a population scale. Astrophysical modeling shows that multiple star systems can be dynamically unstable over long timescales. Over millions of years, such systems tend to eject one of the stars or rearrange their orbits violently. If Earth were caught in this chaos, it might eventually be flung into interstellar space, condemned to a frozen death, or spiraled into one of the suns in a fiery obliteration. Either way, the long-term sustainability of a planet like Earth in a multi-star system is incredibly unlikely. Much Adventure's experiment, while presented with humor and curiosity, echoes a deeper truth. We live in a fragile balance. Our single-star system is an anomaly in a universe where binary systems are more common. The fact that we're here on a planet stable enough to develop life, civilizations, and science is nothing short of a cosmic miracle. But what about civilizations out there, thriving in multi-star systems right now? Imagine heated worlds locked in a fiery tug-of-war between suns, a reality straight out of Star Wars. Twin shadows, unpredictable skies, and endless possibilities. Would you dare to experience such a world? Or is our peaceful blue planet good enough for you? Share your thoughts, and let's meet again in our next mind-bending cosmic adventure.